Assalamu alaikum and good day everyone. So today we are going to continue with lecture 3 of 5, which is we are going to focus on 5.3, which is the inverse functions. So the learning outcome for this lesson, at the end of the lesson, students should be able to use algebraic approach or horizontal line test to determine whether a function is 1 to 1. Determine whether the inverse of a function if it exists. So we want to find the inverse. Find the domain and range for an inverse function. And lastly, to sketch the graph of f and f inverse on the same axis. Okay. The first one is to check whether the function is 1 to 1. We have two methods. The first one by using algebraic approach. The second one is by using horizontal line test. Previously, we used vertical line test to check whether it is a function or not. But now, to check whether it's a 1-to-1 function, we can use the horizontal line test or algebraic approach. And then, we can try to determine the inverse of a function if it exists. So how can we know that the inverse exists or not? So we will learn it together. And then, as usual, for a function, we need to know how to find the domain and the range, and also to sketch the graph of the inverse. But not only the f inverse, we need to sketch the graph of the original function f and its inverse on the same axis. So 1-to-1 function. A 1-to-1 function is a function in which the answer never repeats. Okay, so means that for every x, it only have one y, and for every y, only have one x. It shouldn't be many. A normal function can have two different input values that produce the same answer, but 1-to-1 function does not. For example, the function fx equal to x squared is not a 1-to-1 function because it produces 4 as the answer when you input both 2 and negative 2. But the function fx equal to x minus 3 is 1-to-1 function because it produces a different answer for every input. Algebraic approach. So function is a 1-to-1 function if for f of x1 equal to f of x2, x1 should be equal to x2. Means that for every output, the same output, it will come from the same input. So how do we find from this into this? So one image should have only one element. So horizontal line test is the graphical method to show that it's a 1-to-1 function. Okay, if a straight line that is parallel to x-axis, so it's a horizontal line, is drawn and it at most cuts the graph at only one. Paling banyak satu point sahaja. At only one point, then the function is 1-to-1. This is known as horizontal line test. Melintang. So let's do example number 1. By using the algebraic approach and horizontal line test, determine whether the following function are 1-to-1 function. So we have A, B, and C. So let's check together. For question A, so if you want to use the algebraic approach, okay, so method 1. So if fx1 equal to fx2, so the input here on the left side is x1, on the right side is x2. So we substitute x1 on the function fx, also x2 into a function of fx on both sides. So we will have 3x1 plus 2 equal to 3x2 plus 2. So to get x1 equal to what? So we have to eliminate other things. So what we should do here, we can eliminate the 2. Both can be subtracted by 2 on both sides. So we have left by 3x1 equal to 3x2. And then to get x1 only, we can eliminate 3 by dividing 3 on both sides. So we will have x1 equal to x2. So means that fx1 equal to fx2 will give you x1 equal to x2. Means it has only one object for every image. So it is a one-to-one function. Now let's check by using the graphical method. So if we draw the graph of 3x plus 2, so let us continue it to the bottom here. So it's a straight line and it passed through an intercept, y-intercept 2 and x-intercept -2 over 3. Now to check whether it's a one-to-one function or not, we use the horizontal line test. So use your ruler horizontally and move the ruler from the bottom to the up. Okay, so we move around along the y-axis, so we can check whether it cuts at one point or more. So if we notice, we move this line around, we can say that it's only cut at one point. So line y equal to k cuts at only one point. Therefore, the graph represents one-to-one function. So B, hx equal to a square root of x minus 2, where x should be more than or equal to 2. Okay, now we have given a certain domain where x should be more than or equal to 2 only. So now to check, we're using the first method, the algebraic approach. So hx1 equal to hx2. So we have a square root of x1 minus 2 equal to square root of x2 minus 2. Now what we need to do is to first, by eliminating the third, so we can put square on both sides. So square both sides, we will have x1 minus 2 equal to x2 minus 2. And then we have to eliminate the -2, so we will have x1 equal to x2. Okay? It is a one-to-one function. Okay, actually, if we want to eliminate this square root, we will square both sides, right? So we will have these results. So it's a one-to-one function. And then if you use the horizontal line test, so this is our graph. So if we want to sketch the graph, so we take the everything under the set equal to 0. So we have x minus 2 equal to 0. So x is equal to 2. So this is the critical point, the x coordinate for the critical point. So when x equal to 2, y equal to square root of 2 minus 2, which is equal to 0. So the critical point is 2, 0. So we have critical point at 2, 0. And then domain x is more than or equal to 2 means that it starts from 2 to infinity. And we know that set x minus 2 always more than or equal to 0. So y is more than or equal to 0. So the range is equal to 0 to infinity. So everything, this one is going to the right, this one is going to the top. So it's going to the right and to the top. So this is the graph. Okay, so after we sketch the graph, we can use the horizontal line. Okay, so this is our horizontal line, and move the line around. So you can use your ruler and move your ruler around from along the y-axis. Okay, so we can say that it only cuts at one point. So line y equal to k cuts at only one point. Therefore, the graph represents one-to-one function. Okay, so let's move on to the question C. So fx equal to absolute x plus 5, where x is an element of real number. So everything in real number is the object. So method 1, by using the algebraic approach, so for fx1 equal to fx2, it will be absolute of x1 plus 5 equal to absolute of x2 plus 5. And then how to eliminate the absolute? We have to use the definition of absolute equation. So what we will have is x1 plus 5 equal to x2 plus 5, and or x1 plus 5 equal to negative of x2 plus 5. Okay, so we have to solve it separately. So what we will have on the left side, we can eliminate the 5 on the left side here by subtracting 5 on both sides. So we directly have x1 equal to x2. But for the right side, what we have is x1 plus 5 equal to negative of x2 minus 5. To eliminate this 5, we subtract 5 on both sides. But on the right side, what we have is negative x2 minus 10. So for this one, x1 has 2 value, means that it's not unique. It's not a one-to-one function because the image give a different 2 objects. Okay, 2 elements mapped to 1 image. 2 objects mapped to 1 image. So it is not a one-to-one function. By using the horizontal line test, so if we sketch our graph, so we can find the vertex first. So the vertex is equal to what? So we take everything inside the absolute x plus 5 equate with 0. So x equal to negative 5. So when x equal to negative 5, y equal to 0. So the vertex is equal to negative 5, 0. And then because it's positive of absolute, so it should be a V shape. Okay, so this is our graph with the vertex at negative 5, 0. Now, to check by using the horizontal line test, so we draw the line, horizontal line. So we can see that it cuts through 2 points, right? So if we move at the vertex, it cuts at 1 point. But if we move up, it will cut at 2 points. So line yk equal to k cuts at 2 points. Therefore, the graph does not represent one-to-one function. So it's not a one-to-one function. Okay, so this is how you check whether it's a one-to-one function or not, whether using the algebraic method or horizontal line test. Okay, so what is inverse function? If f of x mapped to y is a function that maps x to y, then the inverse function written as f negative 1 is a function that maps y back to x. So it's going back. So this is the arrow diagram. So if a function mapping x to y, then this y will map to x back by using the inverse function. Means that it will give you the itself, x itself again, if you do the inverse after you find the f. So means that f of f inverse, the composite of f inverse is equal to x. Okay, so if f of f inverse of x is equal to x, or f inverse of fx is equal to x, means that we have the inverse. If a function is to have an inverse, the function must be one-to-one and onto. That is, every member of its domain is mapped to its own unique member of the range. So all x should have the partner in y, okay, and its own unique members. A one-to-one function can be determined by using algebraic approach or graphical approach, which is the horizontal line test. Example 2. So let's find the inverse of fx if it exists. So how to show that the inverse is exists? And then show that fx equal to x squared plus 5, where x should be more than or equal to 0, has an inverse, and find the inverse fx f to the power of negative 1x. Okay, now for question A, find inverse of fx equal to 3 minus x if it exists. So we have to show that it exists by to check whether it's a one-to-one function. Okay, a function have an inverse if it's only a one-to-one function. So to show that it's a one-to-one function, we have two methods, right? Earlier we learned by using algebraic, or to show it exists, we have to show that it's a one-to-one function. So to show that it's a one-to-one function, we have two methods: algebraic method or horizontal line test. So now if you want to use the algebraic method, we start with fx1 equal to fx2. So we replace the x with x1 and x2. So we have 3 minus x1 equal to 3 minus x2. So eliminate 3. So subtract 3 on both sides. We have negative x1 equal to negative x2. And eliminate negative, we multiply with negative 1. So we have x1 equal to x2. So it gives you a unique object, means that it's a one-to-one function. Therefore, f inverse exists. Okay, so after that, what we have to do? To find the inverse. So how to find the inverse? To find the inverse, we will use this special properties of inverse, means f of f inverse x equal to x. Okay, so this method, we need to use our skill in finding the composite. Okay, so we know what is fx, right? So this is equivalent to f of f inverse x equal to x. So we know already what is our f. So what we want to find is f inverse, which is, this is an inner function. So if we remember back the composite method we learned to find the inner function, so we just apply that. So what is fx? So fx is equal to 3 minus x. So if it's an f of f inverse, means that we have to replace the x with f inverse. So what we have on the left side is actually 3 minus f inverse x equal to x. So what is f inverse x? So we just have to rearrange, let the f inverse x will be the subject lah. Jadikan f inverse tu sebagai perkara rumus. So apa yang kita dapat, f inverse x is actually equal to 3 minus x juga. Okay, kat sini kan kita nampak that we can see that the f inverse x is actually equal to the f inverse, the f itself. Okay, now we found the inverse. For question B, show that fx equal to x squared plus 5 for x more than or equal to 0 has an inverse. So we want to show that it has an inverse. We can use either algebraic or graphical method. So you can choose either one if it's not stated in the questions. So now, if you want to use the algebraic method, so fx1 equal to fx2, we have x1 square plus 5 equal to x2 square plus 5. And then, so we eliminate the 5 both sides. So we have x1 square equal to x2 square. So to eliminate the square, what we need to do, we have to square root on both sides. So if we square root, means that we have a plus and minus there. Okay, so it should be x1 equal to plus minus square root of x2 square. So that's why we have eliminated the square and square root. So we have a plus minus of x2. So x1 has x2 or negative of x2. Now, because we can see that it's not a one-to-one function, because we have two objects for the same image, but they give you this value, x should be more than or equal to 0. Means that Since x is more than or equal to 0, we only take the x1 equal to x2. We have to reject this one, right? Because it's a negative value, so we cannot take the negative value. So it's a one-to-one function. Therefore, the F inverse exists. Understand? Okay, so now we continue to find the inverse function. So to find the inverse function, we use the same properties. F of F inverse x equal to x. Okay, so what is f function? So this is f of F inverse x equal to x. So f function outside is equal to fx equal to x squared plus 5. So we replace the x with f inverse x. So we have f inverse x squared plus 5. So to let f inverse x as a subject, so we have to bring the 5 first. So we have f inverse x squared equal to x minus 5. And then to eliminate the square, so we have to put square root on both sides. So we have a plus minus of square root x minus 5. But since x should be more than or equal to 0 for fx, for f inverse means that the y should be more than or equal to 0. Okay? Or f inverse x should be more than or equal to 0. Okay, remember, this is x, this is y. So x to y is a function. So y get back to x by using f inverse. Right? So if x for f should be more than or equal to 0, it means it's the y for f inverse. Okay? That's why f inverse of x should be more than 0 because x is more than or equal to 0. Understand? Okay, so we relate that if x more than or equal to 0 means that f inverse x should be more than or equal to 0. So f inverse x, we should take this is positive value, so we take the positive set only. So f inverse of x should be equal to square root of x minus 5 only. So we have to reject the negative one. Understand? Okay, so let's continue. Example 3. The function of f and g are defined as fx equal to 2x plus 3 and gx equal to x minus 1. So now we want to find A, the f inverse, B, the g inverse, C, f of g inverse, D, f inverse of g inverse, and E, f of g all inverse. Okay, now let's continue with A first. Okay, so for A, we want to find f inverse. So fx is equal to 2x plus 3. So every time we want to find the inverse, we need to use the properties of f inverse equal to x. So f of f inverse equal to x. What is our function f? It's a 2x plus 3 for x. So if we replace x with f inverse, what we have? We will have 2f inverse plus 3 equal to x. And then let the f inverse as the subject, we will have f inverse is equal to x minus 3 over 2. So this is the answer for f inverse. How about B? We want to find g inverse, right? So the same properties we need to use is g of g inverse x equal to x. Okay, so what is our g? Gx is equal to x minus 1. So if we replace the x with g inverse, so we will have g inverse x is equal minus 1 is equal to x. Right? And then g inverse is actually equal to x plus 1. So we have both f inverse and g inverse. So now let's continue to solve for question C. So we have already f inverse and g inverse. So for question C, to find f of g inverse x means that we have function f and composite with g inverse x. So now we replace the g inverse first. So we have found out the g inverse from question B. So g inverse is equal to x plus 1. So it's f of x plus 1. And then we replace the x in fx with the x plus 1. Okay, So this x here we replace by x plus 1. So we have 2 of x plus 1 plus 3. So simplify everything. So we have 2x plus 6 plus 3. We get the 2x plus 2 plus 3. So we have 2x plus 5 as the results. Now for question D. F inverse composite with G inverse x. So F inverse of G inverse x. So we have G inverse, same as the question C. So we replace by x plus 1. And then we replace the x plus 1 with x in the F inverse. So we replace with x here to be x plus 1. So what we have is x is replaced by x plus 1. So we will have x plus 1 minus 3 over 2. So simplify, we get x minus 2 over 2. Okay, so this is for question C and D. Now continue with question E. F of G and then inverse. What this means, so we have to composite the F and G first and then to find the inverse. So find the composite of F of G. So F of G is equal to F of Gx. The Gx is replaced by x minus 1. And then the x in the Fx we replace by x minus 1. So it will be 2 of x minus 1 plus 3. So we have 2x minus 2 plus 3. So it's equal to 2x plus 1. So now we have the F of G. To find the inverse of F of G, okay, so now first, before we find the inverse, to make it simpler for your works, so if you want to find inverse means that we have to use the properties, right? So the properties is F of F inverse. So now we have F of G. So to find F of G, composite with F of G inverse of X, it will be complicated, right? So we use a representation of F of Gx. How? By using the letting Kx equal to F of Gx. So if we use the Kx letter, if we know Kx, K inverse of X is equal to F of G or inverse of X. So what is Kx? So directly Kx equal to 2x plus 1. So K composite K inverse of X, we get it equal to X. This is the properties we will use to find the inverse. So K of K inverse X equal to X. So what is K? K is 2x plus 1. So if we replace the X here with K inverse, so this x on the right side also need to be replaced by K inverse. So 2 of K inverse x plus 1 is equal to x. So let the K inverse as the subject. Okay, so what we have is x minus 1 and divide by 2. So F of G inverse x is equal to x minus 1 divided by 2. Notice that F of G inverse x is not equivalent to F inverse composite with G inverse. So we can check back with question number D. Okay, so this is for the example. So next. Okay, now let's move on to the next part of this lecture, which is the domain and range of an inverse function. Okay, so the output of the function f are the input of f inverse. Means that what are the outputs of function f? So we usually represent it as y. So this y is actually the input of f inverse. So what is the output for f inverse? So it should be x. So the range of f is also domain of f inverse. So the y will be the domain of f inverse. Likewise, because the inputs of f are the outputs of f inverse, the domain of f is the range of f inverse. We can visualize the situation. So this is the domain of f, the range of f. And then, after we map into x back by using the f inverse, this one, which is the y, the range of f will be the domain of f inverse, and then this x will be the range of f inverse, which is it's the domain of f. Therefore, we conclude that the domain of f is actually the range of f inverse. Range of f is the domain of f inverse. So let's see the graphical illustration of an inverse function. So the inverse of fx is equal to 2x minus 3 is f inverse equal to x plus 3 all over 2. So there should be fx here. So if we draw the graph, so for fx, so we have 2x plus 3 with negative 3 as the y-intercept and 3 over 2 as the x-intercept. So this is our graph. And then for the f inverse, we have 3 over 2 as the y-intercept, right? So this is x over 2 plus 3 over 2. And then negative 3 as the x-intercepts. 3 over 2 as the y-intercept, negative 3 as the x-intercepts. So we have this line. Okay, so notice that these two graphs is crossing each other and it's actually reflecting on the y equal to x axis. Okay, so the x for y, the x for fx is the y for f prime, f inverse x, and the x for f inverse x is the y of fx. Okay, because it's reflecting. So let's say for this point here, let's say this point here is 1 and 1 and not 1, 2 and 1, 2 and 1. This is 0.21. Reflecting on the y equal to x axis, it will be 1, 2. So this is on f inverse fx. Okay, so the graph of y equal to fx and f inverse x are reflection of each other about the line y equal to x axis. So if you want to sketch the graph later, means that you can just reflect on y equal to axis, y equal to x axis. Okay, let's say we know how to sketch the graph for fx. So if the question asks you to sketch both fx and f inverse x on the same axis, means that you can just reflect on y equal to x axis. Okay, so the inverse of function fx equal to 9 over 5x plus 32 was found to be f inverse of x equal to 5 over 9 of x minus 32. So to sketch the fx graphs, so we have an intercept at 32, y-intercept at 32, and x-intercept at negative 17, 7 over 9. So we connect these 2 points to get the graph of f. And then another graph f inverse will have an y-intercept at negative 17, 7 over 9 and x-intercept at 32. Okay, so this value intercept, y-intercept, will be the x-intercept for the f inverse. The x-intercept will be the y-intercept for f inverse. So these two graphs are reflected on each other by the y equal to x axis. The figure shows the graph of these two functions on the same pair of axes. The dotted line is the graph y equal to x. This graph illustrates a general relationship between the graph of a function and that of its inverse, namely that one graph is the reflection of the other about the line y equal to x. This is an interesting group of functions which have graphs that are symmetrical about the line y equal to x. Note that df is equal to rf inverse, rf equal to d of f inverse. Example 4. A function f is defined as fx equal to negative x squared plus 5, where x must be more than or equal to 0. Find the inverse function. State the domain and range of inverse function. And given the graph of f, sketch the graph of f inverse on the same axis. So this is the graph of f. So now we want to sketch the graph of f inverse on the same axis. So the easiest way for question number 3 is to do the reflection about the y equal to x axis. Okay, if not, then you just have to sketch from the inverse function found in question I. So let's do question A1 first. So to find the inverse function fx equal to negative x squared plus 5, so we use the properties of f, composite f inverse equal to x. So f of f inverse equal to x. So we replace the x in f as the f inverse. So we have negative of f inverse squared plus 5 equal to x. And then we bring the 5 to the right side. So we have negative f inverse square equal to x minus 5. So eliminate the negative, we have 5 minus x, and then eliminate the square, we put square root on both sides, we have square root of plus minus square root of 5 minus x. And then because x is more than 0, so this is domain of f is 0 to infinity. This is equivalent to the range of f inverse. Means that the f inverse itself should be more than or equal to 0. So, the f inverse, the final answer for f inverse of x is equal to, yes, we take the positive only because it should be more than or equal to 0. So, f inverse of x equal to square root of 5 minus x only. Okay, now, for the domain and range of f inverse, so previously we know that the domain of f is equal to x more than or equal to 0. So, what is the domain of f inverse? So, directly we see that the f inverse is a square root function. So, how do we find the domain for square root function? Yes, we take everything inside the set and we more than or equal to 0. We have to make sure that it is a positive value. So, 5 minus x is more than or equal to 0. So, x should be less than or equal to 5. So, the domain for f inverse is equal to negative infinity up to 5. So, what is the range of f inverse? Range of f inverse is equivalent to the domain of f, which is equal to 0 to infinity. Okay, so this is for question I2. For the third one, to sketch the f inverse function, so we have the function f already. What you need to do is just to reflect f inverse at a line of y equal to x. So if we have y-intercept at 5, so we will have x-intercept for f inverse at 5. And then you just have to reflect. So how do you do the transformation in high school? For this line, you usually will you akan lipat kertas, betul tak? You will fold the paper and then you draw on the other side, right? So we do the same. So now this one is going to this side, so it will meet at one point and then continue to this other. So the graph should be like this, so it will reflect this point, reflect here, here, reflect here, and so on. So this is our graph reflecting on the y equal to x axis. Or you can use the f inverse function, which is equal to square root of 5 minus x. So what is the domain? We know the domain is equal to 5. Sorry, the domain is equal to negative infinity, right? So negative infinity up to 5. This is the domain of f inverse, and the range of f inverse is equal to from 0 to infinity. So here it's going to the left, and here it's going positive, so it's going up. So the graph should be going to the left and up. That's why it's going to this sides. Okay, so you can sketch using these two methods. Okay, now, so we continue with question B of example 4. a function f is defined as fx equal to square root of x minus 2, where x should be more than or equal to 2. So the first question is to find the inverse function, and then state the domain and range of f inverse, and given the graph of f, sketch the graph f inverse on the same axis. So they give you the graph f inverse fx on the axis here, so they want you to sketch the f inverse on the same axis, means that sketch on this picture. Okay, now to find the f inverse, so we can use the f of f inverse equal to x properties. So f of f inverse equal to x, we have fx equal to set of x minus 2, so we replace the x with f inverse. So we have square root of f inverse minus 2 equal to x. So to eliminate the set, we square both sides, so we have f inverse minus 2 equal to x squared. So f inverse is equal to x squared plus 2. So we have the f inverse here. Now to find the domain and range. So the domain and range, so we know that the domain of f inverse is equal to x is more than or equal to 2. So it's equivalent to the range of f inverse. How about the domain, the range or the domain of f inverse? Okay, since we can find the range of the f by letting the y. So set square root of x minus 2, we know it's always positive, more than or equal to 0, means that y is always more than or equal to 0. So the range is equal to more 0 and 0 to infinity, which is equivalent to domain of the f inverse. Okay, now for the third one, to sketch the graph of f inverse, we can just reflect f inverse x at line y equal to x. So we have the graph of f already, so we just have to reflect at y equal to x. Or you can just sketch the graph f inverse of x equal to x squared plus 2. Okay, so this is our graph. Right? If you just reflect, this x-intercept 2 will be the y-intercept at 2. Really easy, right? If you just reflect, so you don't have to do from the sketch and to note the domain and range everything to sketch the graph. Okay. So we have the question C. So question C, a function f is defined as absolute x minus 3 and then plus with 1, where x must be more than 3. So to find the inverse function, state the domain and range of f inverse and sketch the graph of f and f inverse on the same plane or same axis lah. So for the first part of it, to find the inverse function, so using the definition of absolute value, so you have to define first for fx. So we have fx equal to x minus 3. So we can define the absolute x minus 3 into x minus 3 and negative of x minus 3, where the x minus 3 must be always positive, and for the bottom one, x minus 3 should be less than 0. X minus 3 is more than or equal to 0. 1 is positive, more than or equal to 0, because in front of it is positive, so we should have positive here. And then the other one is less than 0, a negative, because it's negative because we have negative sign. So negative multiplied with negative will be positive. So it means that x minus 3 when x is more than or equal to 3, and negative of x minus 3 when x is less than 3. So notice that the domain given here is x more than 3. So we only take the x minus 3 in the fx. So fx is x minus 3 plus 1, which is equal to x minus 2. Okay? So to find the inverse, we use the properties of f inverse x equal to x. So f of f inverse equal to x. So we replace the x here with f inverse. So we have f inverse minus 2 equal to x. So f inverse equal to x plus 2. Okay, so what you need to do first before you find the inverse is to define the absolute by using the absolute values definition. For question number 2, we want to find the domain and range. So because we have the range for the domain for the f already, so we can find the range for f inverse, which is equal to from 3 between 3 up to infinity, right? 3 is not included, so this is the domain of f, which is the range of f inverse. And then the range of f, which is the same as the domain of f inverse. So we know that the absolute always positive, so we add up with 1, so it's always more than or equal to 0, and then add up with 1, so the y is always more than or equal to always more than 1. So the range for f is equal to between 1 up to infinity, so it's equal to the domain of f inverse. Okay, so you do the same thing in the finding the domain for the absolute, then the range for the absolute notation. Okay, so the last one is to sketch the graph. So we want to sketch the graph f and f inverse. So how to sketch an absolute graph? So you have to look at x and y axis, look at the critical point or vertex, and then so we have x minus 3, we cut to 0, so x equal to 3. So when x equal to 3, y equal to 1. So 3, 1 will be the vertex there, and then it's going to the right, so it's going up lah. So you can try to put 4 or 5, and then you can see that it's going up. So the graph is going up. And then to find the f inverse, we just have to reflect on the y equal to x line. Okay, so we have this graph. Okay, so this point here is 3, 1. So for the f inverse, it should be 1, 3 lah. So we just have to swap the x and y coordinate. Okay, let's discuss the next question, example 5. Given that fx equal to negative x squared plus 8x minus 6, where x should be more than or equal to 4, find the inverse of function f. Then sketch the graph f and f inverse on the same plane, and find the domain and range of f inverse. Okay, so for the first one, to find the inverse of fx equal to negative x squared plus 8x minus 6, so as usual, we have to use the properties of f inverse. Okay, before that, to make it easier in finding the inverse of quadratic function, so we have to use completing the square to make it simpler. Okay, why? Because to find inverse of a quadratic, it's this way is better lah. So remember how to do completing the square. Okay, so we have a equal to negative 1, b equal to 8, and c equal to negative 6. So b over 2a is equal to negative 4. So doesn't matter, but we do the completing the square. So first we factorize out the the negative from the x squared and 8x. So we have x squared minus 8x minus 6 biar dia tepi. And then after that, what we need to do, it should be x squared minus 8x plus with the b over 2. So what is our b? This b is negative 8 over 2 square and minus of negative b over 2 square. Okay, so this one in the bracket of negative minus 6. And after that, what we have, this part will be a complete square. So negative of x minus x plus with negative 8 over 2 will be minus 4 square. And then here we will have minus of negative 4 square minus 6. Okay, so we have here it's negative, and then don't forget to open the bracket. So we have negative of x minus 4 all square and plus, so negative will be plus, negative 4 is square is equal to 16 minus 6. So we have fx equal to negative of x minus 4 square plus 10. So now we can find the inverse. Okay, now to find the inverse of this, let me clear this side first. Okay, so we use the same properties now, which is f of f inverse of x equal to x. So what is the replace? We replace the x here with f inverse. This x here with f inverse. So we have negative of f inverse minus 4 all square plus 10 equal to x. So minus 10 on both sides, and then multiply with negative on both sides, and then eliminate the square here. So we have square root plus minus square root, and then this negative 4 will be positive on the right side. So we have f inverse of x equal to 4 plus minus square root of negative x plus 10. But remember, the question gives that when x is more than or equal to 4. More than only, sorry. So it's more than, not more than equal. So we should take more than equal, sorry. Because x is more than or equal to 4, this is the domain of f, means that the range of f inverse will be more than or equal to 4. So f inverse of x should be more than or equal to 4. So we only take 4 plus square root of negative x plus 10. Okay, so now we have the f inverse. Then we can find a graph. So sketch the graph. So as usual, for quadratic, we sketch the x and y axis, and then locate the minimum and maximum point because it's a quadratic, right? So because we have the complete square form already, so we can directly know what is the minimum or maximum point. So because it's a negative graph, so it should be a maximum point lah. So maximum point at 4, 10. And then sketch the graph of fx. And then reflex to get the f inverse. So now we sketch our graph of fx. So we have a maximum point at 4, 10. And then the graph, it should be more than or equal to 4. So if no limitation for the x, so it should be like this. But because we have the domain for f, which is the x should be more than or equal to 4, so the graph should be on the right side of this only, the right side of 4 only. Okay, now to find the graph of f inverse, so we just have to draw the y equal to x line, and then the point for 10 will be 10 for here, and then we reflect on the y-axis, so it's going to this side. Okay, so the intersect between these two graphs should be on the y equal to x axis. Okay, so this is our two graph, f and f inverse. Don't forget to label the graph, the one with fx, the one with f inverse. Okay, so we are done, right? Oh, how about the domain and range? So the domain and range of f inverse, we can see from the graph, or we can look at the domain from the f and find the range. Okay, now if we just look at the graph, the x for the f inverse is taking the value below 10, right? The left side of 10. So the domain should be negative infinity up to 10. And then the value of y is starting from 4 up to infinity. So that's why it's starting from 4 to infinity. Okay, so we have the graph, so it's easier to find the domain and range directly from the graph. Okay, so that's all for inverse. So what do you learn about inverse? First of all, we have to know how to check whether the graph is a one-to-one function. So if it's a one-to-one function, then it will have an inverse. Then determine how to find the inverse, to find the domain and range of inverse, and to sketch the inverse function. on the same axis of f function. Okay, so that's all for this lecture. Thank you everyone. Please try to do the tutorial question of f inverse. This is wajib punya soalan, so you have to conquer it. Okay, thank you class.